Good evening. I welcome you all for today's session, Parity Generator or Checker. We are going to discuss both Parity Generator and Checker in this session. So the Parity Checker's main function is to detect errors, which was this concept is introduced in 1992. So what is the role of parity? What is a parity bit? What is the role of a parity bit? So while transferring data from transmitter to receiver, in the receiver end, we may occur some error. So this parity bit checks whether there is any error in the data while transferring from transmitter to receiver. So this is also named as error detecting bit. Parity bit is also named as error detecting bit. If even parity bit, there are two types of parity bit. One is odd and another one is even. These are the two types of parity bits. So in odd parity, the output must be in an odd number of ones. For example, if you are taking 5-bit code like 100011, this code is said to be odd parity because there is 3 number of ones in the code which we have taken. In even parity bit, the code must be in even number of ones. For example, we are taking 6-bit code 101101. This code is said to be even parity because there are 4 number of ones in the code which we have taken already. So this is parity generator. What is a parity generator? So far we discussed about parity bit. Now we are going to discuss about parity generator. What is a parity generator? So this parity generator is a combination circuit at the transmitter. It takes an input and generates the parity bit. For that message, takes a message and generates the parity bit, and for that particular message, and the message is transmitted along with its parity bit. So we have some data bit already. Parity bit is nothing but we are adding some additional bit along with the data bit. That is said to be as parity bit. So this parity bit is parity generator is classified of two types, like even parity generator and odd parity generator. So this is the truth table of parity bit for both even and odd. First let us discuss about even parity. I have taken 3 bit like ABC. In 8421 code I have written the inputs, and for even parity, from the inputs, if it is 001, it is already even, so I no need to add any additional bit, so I have just given 0 as my output. Next, if it is 001, it is in odd condition, so I need to add one additional bit to make it as a even, so my output is 1. Next, 010, same, it is in odd condition, I have to add one additional bit to make it as even. Next, likewise, from 00 to till 7, we have added for 1 for the odd numbers and 0 for the even numbers. So this is my truth table for even parity generator. Suppose for this particular truth table, we have to plot K-map for the output even parity, and this is the binary equation of the even parity. So with the binary equation, I have drawn the logic circuit. So this is the logic circuit of even parity generator. So same vice versa, like even parity, we have to form the truth table for odd parity. So as I said, for even, this odd parity generator maintains the binary data in an odd number of ones, for which it is taken in the even number of ones. So this combinational circuit whose output is always dependent upon the given input data. If there is an even number of ones, then only parity bit is added to make the binary code into an odd number of ones. So this is the truth table for odd parity generator, as if the truth table, in this truth table, the vice versa, if your input is even, we have to add 1. If your input is odd, then your additional bit will be 0. So as vice versa of even bit, we have to make the output additional bit to make the input as even. That is said to be as odd parity. So for the odd parity. So this is the truth table for odd parity, and K-map. With the K-map we have designed the logic circuit. So this is all about parity generator and parity checker. So in this combinatorial circuit at the receiver we have a checker circuit. This takes the received message including the parity bit as input. If there is some error found and gives output 0, and if there is no error, then the message including the parity bit, it will transmit the message from transmitter to receiver. So here also we have two types, same even parity checker and odd parity checker. So this parity checker will be in the receiver end. This is all about parity generator and parity checker. Thank you.